So the first operation I'm going to do is the drilled and tapped holes for these set screws here. These are 1032, and I'm doing those first because I've got to hold it up in the vise like this, and if this hole was here first, I might accidentally crush it a little bit with the force of the vise. From there, I'll go ahead and drill and ream this hole, and then I'll go ahead and drill and tap these two. I'm going to do the reaming first, even though I'm going to leave a burr on the inside with these tapped holes, because I want to feel when these guys break through. I don't want to accidentally drill through the part. I can always go back with the reamer and run it back through and clean up any burrs that are created by these tapped holes. The very first thing I need to do is find my edges so that I know where the spindle center line is in relation to my part. And don't forget that you need to compensate for half the diameter of the tip on this edge finder. So the tip is 200 thousandths, so after it kicks off, you have to move in 100 thousandths in order to put the spindle center line over the edge of the part. I did that in both axes. So I'm in position for my first hole, and I've put a 90-degree spot drill in here. The idea here is that this is not only going to spot for the tap drill, but it's also going to leave the chamfer that I want for the tapped hole. You always want to have a chamfer on any tapped hole before you tap it, otherwise you raise a big burr. You can go ahead and deburr it afterwards with a countersink, but that tends to screw up that very first thread. So just make your life easier, put the chamfer on before you tap. Now, if you haven't watched my video on consistent countersinks and spots, what I'm doing here is I've actually got the quill fed down against the quill stop, and I'm going to feed up with the knee until I get the right size diameter chamfer. And then when I move to this one, all I need to do is feed it down against the quill stop again, and I'll have the exact same size chamfer. That looks like it ought to do pretty nicely. I don't want it too big because it's really close to breaking over the edges right now. So at this point, I just have to move over to the other location and just feed down against the quill stop, and my spots are done. So now I have two identical spots, two identical chamfers. I could just switch to the tap drill and drill to the correct depth. In this case, the material at the back side of the threads is going to get machined away, so I can go ahead and drill a little bit deeper. The width of this feature is 400 thousandths, but I'll probably drill about 700 thousandths in just to make sure that I have enough room for the threads that I'm creating. These are 1032 holes, so I'm using a number 21 drill bit. You saw me peck drilling there, so I went in a little bit and then withdrew, and that's to make sure they clear the chips. So right now I've got blind holes, so I don't want to break this tap off in them. So what I'll do is just get it started and then back it back out, and then after the groove is cut into it, I can go ahead and finish it up by hand. So if you haven't watched my video on power tapping in the mill and the lathe, you might want to check that out as well. Basically though, you just turn it on nice and slow, and once the tap grabs, it's going to feed itself in, and then you just throw it into reverse when you're ready and it'll feed itself back out. I'm setting up right now for the drilled and reamed hole, and I want to point out a couple of little things. First of all, I'm going to be drilling and reaming right through here, and it's going to be very close to the edge, so I only have one parallel in, and it's on this jaw right back here. That way when I drill through, it doesn't go all the way through and into my parallel. You really only have to drill into parallels once to figure out that you don't want to do it again. Another thing to consider is that the distance between this edge over here and the hole is the same between this edge and the two tapped holes that we're going to have to create next. It would be really handy actually to have a vise stop or a table stop set up, but I'm assuming that most of you don't have one already since you're watching this video. So one thing you can do is take a parallel, in this case it's the other parallel, the pair to this one, and you can bump up against the side of the vise jaws and bump your part up against that before you tighten it. In this case, these are just set screw holes that are going to be holding that pin in, so this is more than accurate enough to do that. So I've tightened it up. I'm going to give it a little love tap. Alright, my parallel doesn't move, it's nice and seated. One last thing is that this side over here is the side that I had already found the edge on for the previous operation, the side with the fixed jaw. I did that because now I don't have to find that edge again. I already know where it is. So 0 is already the spindle center line right over the edge of this fixed jaw, and therefore right over the edge of this part. So I'm just saving myself a little bit of time there. So even though I still know where this edge is back here, I still need to find this one. So I'm going to go ahead and do that now. And again, don't forget to compensate for the diameter of the tip. I switched back to my spot drill, and in this case I'm not looking for a chamfer, so I'm just going to give it a little bit of a smooch for my number 31 drill to follow. I'm going to use a number 31 drill here, which measures in at 120 thousandths. That should give me enough meat to go ahead and take out with my reamer afterwards. This is a small drill, so I've bumped up my speed on my milling machine as well. I'm going as fast as I can go, which is 2720. I'm all the way through the part. Now it's time to switch to the reamer. I've just switched to my 126 thousandths reamer. This is a thousandth over 1/8 of an inch. This is going to allow our pin to be able to slip through easily, and it'll just be held there by the set screws. This way you can adjust it to any position that you want without too much trouble. If you don't have an over-under reamer set, which would give you a thousandth over and under each fractional size, no worries. I mean, you can get these reamers individually from MSC or McMaster-Carr or any of those other suppliers, and they're not that expensive. This reamer is probably about $5. Reamers do have a couple of rules of thumb that you need to follow. The biggest one is that they should be run at half the speed and double the feed of a similarly sized drill. So in this case you would figure out what is the correct drilling speed for mild steel with an 1/8 inch diameter drill, and then you just cut that in half. As far as feed rate goes, on a manual machine you're just feeding through by feel anyway. On a CNC machine you can actually specify your feed rate, and you would do twice as much as what you would for drilling. You also want to make sure that you use a ton of oil, especially in steel, otherwise the reamer can go oversized and it won't necessarily leave the best surface finish if you don't use a cutting fluid. That's all there is to it. So now we're ready to drill and tap the two holes that are going to intersect with this pinhole. And remember, before I just bumped up the edge of the part using a parallel against the side of the vise jaws. We're going to do that exact same thing here and then tighten up the vise. And this is going to get us well within a thousandth of an inch, certainly good enough for two set screw holes. And then now we don't have to find the edge on the x-axis again because we pretty much already know it. And again, we already know the y-axis as well because we used the fixed jaw when we found our edge. There we go. Alright, those are nice and stable. So now I just have to go to my hole locations and drill and tap just like before. So I'm spotting the holes, and I'm doing the exact same trick that I did before where I'm feeding against the quill stop, and that way I get consistent chamfers. For that I just went until I broke through into the hole, and you can feel that pretty easily. So I'm about to tap these holes, and even though they break into a hole, I'm still kind of considering them blind holes because I don't want to run into the other side of that hole, and it's relatively small in diameter. So I'm going to do the same thing that I did with the other ones and just start them and then finish them by hand later. Okay, Time to move on to the grooves. I'm set up now to do my grooves, and this is where laying out is really helpful because I can touch off on my cutter and I can make sure that my cutter is well away from the lines that I've scribed in there to make sure that I don't accidentally machine the features undersized. So I've touched off and moved off my part and moved my knee up just a little bit so I can go ahead and take my first pass. After this pass, I'll be able to take a measurement and see how far I need to go for my goal for the 2 steps, as well as the length of each of those features. That was a pretty light cut, but now I should be able to measure from this surface to the opposite side and see how far I need to go in order to get to my depth. I know my first step needs to be 100 thousandths deep, so this measurement should be 350 thousandths. And then the second one is 200 thousandths deep, so that measurement should be 250 thousandths at the end. So I'm just about done with my first step. I've got a little bit more to take off on the underside and 20 thousandths there. I've got a little bit of extra on this side too, but I'm going to take that when I get down to my full depth to make sure that I get one nice smooth finish. So we're perfect here on this thickness and this length, and I've re-zeroed my knee, so now I know that this surface is 0 and I just need to move in another 100 thousandths from there. I also know where this surface is over here. I've got that on my digital readout, so I should be able to get the rest of the steps done pretty quickly. That cut there was to establish a datum for this step, so now I can take a measurement from there to there and see where I am. So I've got 49 thousandths to take off still on this step, and I should still have some thickness to take off of the bottom. I'm going to take my first finish pass here, and I'll take away most of this bulk on my second pass through. That should have left me 10 thousandths on this step, and on the bottom, so I'm going to just take some measurements real fast. That should just about do it. I'm going to take some last measurements before I take it out of the vise just to make sure, and then I've got a lot of deburring to do. So everything came out in spec, and I've got everything deburred. I went ahead and tapped the holes, both these 440 ones there and the 1032 ones back there, and I've also run a reamer back through this hole for the pin. So now I just need to put the fasteners in there. I've already gone ahead and cleaned off my layout fluid as well, so you can see that's nice and clean looking. They do have layout fluid remover, but actually what I used was just AutoZone brake cleaner. It works just as well. I know someone's going to ask me about these grooves from the drilling for the 1032 holes, and I've got a little bit of threads in there too. That shouldn't matter at all. This is just sitting on top of the vise jaw, so it's not like it's taking any load at all. And the reason I used 1032 rather than 832, which would actually fit in that space, was because it was a larger Allen wrench, so I could tighten it down just a little bit easier. I hope you like this project, and hopefully everyone that watched it will run out to their shops and make one right now, or at least in the near future. If you did find this video helpful, please consider hitting the like and subscribe button below. Thanks for watching, and I'll see you next time.